Boom. So all lectures are now recorded and on YouTube. Okay. So typically I post those later in the day. So you can go to my YouTube channel, or you can go to, or I'll post links to that. Try to remember. Poke me if I don't. Okay. But that's a reliable way to get things recorded. Okay. So let's talk about test suggestions. This is a grab bag of test things today, some of which are pretty important. I mentioned test-driven development last time. Make the test first, make the program run using the test, make sure it passes the test, and then make it right. What do I mean by make it right? It's sort of a slogan of test-driven development. Make the test, make it run, make it right. What's the make it right?
Never fail every test.
Well, that's true, but that's actually make it run. Let's make it right. Sorry? So it's actually about refactoring. It's about how many people here know what refactoring is? Okay. Can you give me a definition?
Refactoring changes the code structure of the function.
Good. Exactly. It doesn't aspire to change the functionality at all. In fact, it wants to preserve behavior of the code. That's another way to put it. But it changes the code structure. Now, why would you do that? To improve the code structure, make it more transparent, more easily modifiable, more extensible, more robust. Lots of good reasons. Document it better, etc. So the idea here is you build some code, make sure it passes all your tests, and then you think about, okay, wait a minute, could this be done more elegantly, more compactly, more clearly, most importantly, etc. Building for testability, we talked some about that last time. Derive some tests from requirements. We noted that you could start doing that right now, hopefully. Should explicitly consider risks. Where are the risks associated with your project, technology-wise? Are there technologies you're talking about combining that no one you can talk to has combined successfully before? If so, that could be an issue of risk. There may be other risks associated with it. For example, on the testing front, there may be some legacy code you're building atop. You don't know how stable it is, etc. Create a prioritized schedule for testing, so what things you put into place first. Decent bug reports. Make sure the testers talk with developers, have good communication back and forth. Use a template. I'll give an example of a template in just a minute for test procedures, but make sure you fill in some standardized information. Unit tests during the builds if possible. And for your size projects, you should be able to do that. You should be able to run unit tests during the build. For larger sort of industrial strength projects, typically unit tests can't all be executed during the build. There's too many of them. It's not decent. Create release criteria. What are the criteria you'll judge by which this is ready to go? That's a very important thing for a lot of projects. Is this really shippable? Well, how many priority 1, priority 2 bugs are associated with it? When requirements change, make sure that's communicated to the team. Often what happens is a subset of the team goes and talks with a stakeholder, and you learn something about the evolution of stakeholder needs or clarifications about the requirements that change your understanding. All too often, those are not communicated across the team. That may not seem like a big deal, but it is a big deal because those people who don't know this updated information will be working off of outdated understanding of how the program should function. And that can lead to real problems in achieving the functionality that is desired. They'll be working towards a different goal, heading towards a different direction. So communicating within your team when requirements have changed is A1 important. Okay? Because remember, the requirements drive the design, drives the code. And requirements drive a lot of the tests. And also the designs which drive the tests. So if people's understanding of requirements are off somewhere within the team, if it's not synced with the rest of the team members, that's just a disaster waiting to happen. It can mean a lot of code, a lot of design, otherwise good, gets thrown away. This is important. A lot of uses to run in a wide range of machines. I have a slide, in fact, on this. distinct test environment. This is something we as developers fall prey to a lot. We're used to running on machines with admin permission or root permission, and that's a big problem. Why is this a problem? So I've seen this in professional software development where this turns out to bite people in a big way. Why is that an issue?
Installing software.
Well, okay, I'm actually saying it's a problem if you're running with admin access on a routine basis.
Oh, I see.
Why is that?
There's a lot of assumptions associated with running into that. You may have read, write directory folders that you wouldn't.
Yeah, exactly. So basically, it will prevent a lot of permissions issues that would otherwise bite a normal user from coming to the fore. Sure, it's convenient for you. You don't have to worry about all these issues, but the average user will have to worry about them, and you're papering them over. You're hiding them. Again, one of the principles is if there's going to be a problem, you want to know about it as soon as possible. And so this may seem like the quickest route to success on your project. Just prevent yourself from getting distracted. But those distractions you're papering over often are signs there'd be failures that would indicate underlying problems in your software, or inconsistencies in how you set your software up for distribution that could pose real problems for users. So make sure when you're running in test environments, you do so without a privileged access. You're not suing to root as soon as you get in there and then running as root. Limited computational resources. Often user machines don't have nearly the level of disk space, nearly the level of memory available, sometimes not the level of network speed or monitor resolution that your machines will have. Some of you might have access to, monitors that are 30-inch, or routinely go over to space where the network speed is extremely high. Try using your program from other places where the network speed is very slow, because that's what the average user will typically be exposed to. In short, take steps to avoid fooling yourself thinking that your machine is a typical user's machine. It's not. It's not. And the quicker you can put yourself into the shoe of an actual user, the better off you'll be. We live in a very privileged world because we are working with the leading edge in computational technology for some projects. We want to make sure that when we're building software for the broader world, that we get an experience of what we like for them. This is particularly key, of course, for testers, but even for developers, it's really important because it may help offload problems that would otherwise just be found by testers. Offload problems from them, help you find them. Different configurations, potentially configuration for different types of users, for example. So don't always use the software as an admin in that software, with admin permissions as granted by the software, or what have you. You may want to reconfigure things over time to change between user statuses, or to make less disk space available, maybe run it on a different drive, or what have you. You may want to run it under different languages. This is one of the first issues when you're thinking about software today. It's a global environment for software. You can't be assuming that your users will have as their primary install language, that they'll be running an OS which is assuming English as sort of the language, the primary language. You want to be sure that your software will scale well to French-speaking users here in Canada. You want to make sure that those who use names, which may not be in English characters, they may be characters which are right to left instead of left to right. They may be characters that don't map to 256 ASCII characters. They may be East Asian languages which require larger amounts to encode. You're going to want to test your system under that. some of the most reliable ways I could test and in fact crash past students' projects are pasting in documents from other languages. Paste in some Arabic, paste in some Chinese. See how well it scaled accordingly. And often it went down in a blaze of fire. Okay, so you want, a final thing though here is, you do want, when you're thinking about test releases to the test team, don't assume that the test team should always just be using the latest build. Often the test team will want to have a stable code base, stable for at least several days, on which to run a suite of tests. Okay? So they may be running whole suites of tests, and they want to keep it stable for a couple days. Now, in the meantime, there's going to be continuous integration going on with the very latest build, testing against the smoke test, but that doesn't automatically get used by the testers. The testers should be working with sort of an approved build that, okay, this is going to testing now. Typically, that's preferred. Let's talk about this. Don't assume obvious bugs have previously been reported. Often they're underreported, and so, if you find something, just don't assume it's a light matter, that this is well known. Quickly report defects, sort of along the same lines. Probe around boundary cases or corner cases. I think this is what was suggested earlier with respect to text fields, for example. You want to look at cases that are at the extreme. Give me an example of a corner case or a boundary case for an input field. Okay, ridiculous number of pages. So like when I ordered, 16,537 pizzas from the real-time POS, the real-time pizza ordering system. That crashed it. And I chose that number deliberately, thinking about maybe how they encoded the thing. Another example would be -1, right? Or 0 pizzas. I want to order 0 pizzas and just see how it responds. Other case would be an empty name field, something like that. I don't have a last name. That may sound weird, but I know a number of people who do not have last names. Okay, good example. Good call. But no, I have the pleasure of direct acquaintance. I'm friends with some people. That is not a
I don't mean to name drop, guys, but I'm friends with you.
Non-reproducible errors. If you see an error that's non-reproducible, it can't be easily recreated, still report it. Don't think, oh, it's not good enough for reporting. Maybe it only occurs once every 10 times. But knowing that it only occurs once every 10 times, for the developer who might be involved with that area of the program, that may be pretty significant, because maybe they've seen it once. And this gives them the conviction, okay, something's really there. This is worth really trying out. It may give testers a sense, okay, let's see if we can narrow this down. Let's see if we can isolate what it may be that's causing this. Is it a race condition between two things? Is it an issue with network congestion, etc.? And it may come to light again. And that may just give a little bit more evidence for under what conditions it occurs. Choosing subject lines for SDI reports carefully. You want to again make it keep the morale up by not gratuitously rubbing people's nose in the fact that their code has bugs. If a bug fix has been made, don't take it for granted. You remember there's a distinction in the whole process of a bug's life or a defect's life. There's a stage where we distinguish between a bug that's reported as fixed and a bug that's actually confirmed as fixed. This is very important. The developer may report it as fixed, but it's not confirmed as fixed until typically a tester and user verifies it. Okay, this is going. The developer sometimes has a sympathetic ear to themselves. They sometimes assume it's gone before it really is, and it's important that that the bug not be closed prematurely. Okay. So if there's a bug fix, check it out soon. Those who are in my 394 class will know that this is particularly key because it can reduce the delay between when that bug might be identified as still there, for example, and further delay the project. So delays associated with bug fixing, bug detection and fixing, are often one of the real problems in software projects because they distend it, they just drag it out. And often you put in a fix now, and you're not sure it will be checked, and you know that any further diagnosis will go on for another week or so. So if you can check these soon, it will let you be much more likely to converge within the limited time frame you have per iteration of software. This is a really big one. Automate tests via interfaces. The interfaces will be different in different cases. In some cases, it might be user interfaces. In other cases, it may be specialized test interfaces. But make sure that you create what are called test harnesses to drive things. So if you have some code that needs to be tested, often what we do is if it's part of an end-to-end test, like a system-wide test, we can test it as part of that. But often what we want to do is we want to build a test that's focused on testing some subcomponent. Maybe it's an integration test and it tests how modules A, B, and C work together to accomplish some functionality. Maybe instead it's something where we want to do some unit testing. In all these cases, we typically need a test harness. So we need some piece of code whose job it is to sort of set things up so you can do the test. So its job in life of that code, it's kind of this temporary scaffolding. It sets things up so that this test can be executed. It initializes this instance of a class with some information so it can then be tested or what have you. The more tests that you can get in code like that, the larger the battery of tests you can run, say at time of a build, or the testers can run to really pound on the product. Try not to rely on manual testing for everything. And one of the key things is the UI here. You heard, those who were here last time may remember that the team for whom Kristen Dragasoff presented made use of software to go through GUI. So it actually pounded on it through the user interface for some of their tests. You don't want to do that for all the tests because it's very slow and somewhat brittle. If that interface evolves, as it often will, the test may have to be rewritten or adjusted. But there's some good products out there. Water is a very common one, web application testing in Ruby. Some of you may have heard of. That's quite popular, but there's no shortage of others. And student teams within this class have made use of a wide variety of systems for testing their front ends, their UIs. Don't rely on that for all your tests by any means. You're not going to be able to test certain unit tests through the UI. That's just not possible. But you can do a lot of system-wide testing. So be sure to use some systems. Now, Kristen had very kindly, I don't know if you folks have noticed, but she had kindly offered to share their postmortem with you folks. And so she sent me mail yesterday with the document, which I actually did have from previous years. And she encouraged me to post it. So it's actually now on the course site. You can go there and find her postmortem, where she'll talk about some of these issues. And one of them that they mentioned was their systems that they use for UI testing. And something we'll come back to with peer reviews. It's very important that the people in the team focus on achieving quality product and don't turn things into witch hunts. Whose fault this is. The question is, how can we make ourselves less vulnerable to this in the future? It may have been person A was involved, or person B, or person C. It may have been due to fatigue or misunderstanding, miscommunication, etc. But what's really key is how can we most effectively fix this? And going forward, how can we prevent a similar thing from coming up in the future? And that is typically not helped. And in fact, typically it goes in bad directions if you start just turning into a witch hunt. Instead, it should be, okay, can we as a team do even better next time? How can we enable you to do better so that this sort of issue doesn't come up again? Pair testing. This is a technique that's extends the pair programming concept to testing. So the idea is that we have pairs of testers rather than just one tester at a time. Testing is a really interesting activity, and when it's done, whether it's done by writing test code or whether it's done manually, there's a lot of creativity involved. How do you most easily test? What could be the problem to simplify it further? What might we cut out? What may be the underlying issues so we could focus in on that, etc. Rotating testers through different features so they're familiar with different features is a way of spreading knowledge and getting additional creativity to bring to bear, extra eyes as well. And again, I mentioned testers and end users should be the ones who close it. This is just a reminder: not every build is typically released to testing. The testing team may be, building off of one increment while work is continuing on towards increment 2 with successive builds and everything. And perhaps there's several releases in here, but it's not being released to testing on every single new build, so that the testers have a common shared understanding. This is just the life of the bugs that we talked about. And then again, this issue distinction between a reporter fix, belief fix, and then reporter fix confirmation. So the developer may view it as fixed based on their observations from their unit tests and their experience trying it. But then the reporter, the user or tester, will typically be resolved to take it to this resolve stage. Okay, and later the test team may confirm, okay, this is really closed. There's a huge variety of test tools out there. If you go and you look at test suites, you'll find a huge amount of stuff. I used to do consulting for a company that had some quite effective test suites in the area of memory leak detection. They ended up being bought out by Rational Software. There's no shortage of other tools though. Test data generators, usability tools to help understand where the user is moving, what things they're focusing on, what areas of the screen are most of their attention being driven to in terms of UI interaction. Coverage analyses. The team last time that was presented in the tutorial, they used, does anyone remember, for test coverage? What fraction of the entire program is being covered by, what fraction of the statements are being hit by a test, or by a suite of tests? What did they use? Coverture. Yeah. But there's others as well. There's a number of different suites out there which will give you coverage analyses. So this can help identify code that's not executed. It doesn't guarantee your program's without bugs if you have 100% coverage. By no means. We'll talk about that. But what it does give you is some face assurance that at least on the first run through, this is not going to crash. And that it's not obvious. If you haven't reached an area of the code, you can't even claim to have confidence that it'll stand up to testing. Or you can't claim that it's been in any way tested. Metrics reporting tools to report, say, if the code is really crufty, if the methods are really long, take an enormous number of parameters, if the loops are very deep, etc. So there's a large number of tools. I will bring your attention to this one, load tools and stress tools. Load testing, testing against large numbers of users, for example. Stress testing, testing it under low memory conditions, for example, low hard drive space. These are really valuable things, and there's tools that will do that.
What a slow network is. Would that fall into that category?
Yes, yes, absolutely. So just doing a stress test where the network is really, really slow. Why might that show an error? What sort of errors might show up if you put it under slow network speed, for example? Yeah, connection timeouts in a big way. How gracefully does your program handle those, or does it thrash? Does it get into a flail mode where it's not really behaving properly? Similarly for low disk space, etc. So I think I emphasized before, testing is all about focusing on high risk exposure, and these are some reasons that things might be risky. Things might be worth really focusing on. Things have been changed recently. New technologies of some sort have been introduced. Technologies that have not been used before. Code is really complex. The design, you're not sure. It was, you didn't have time to really think through all these issues. The coding has been really rushed. People are really fatigued during it. Lots of dependencies on other areas of the program. Ambiguities in the requirements for this area. Maybe even within your team, there's different perceptions on how it should behave. Maybe some areas have undergone little unit testing, and so you really want to bang on them more. You know that this area of your program has the unit tests, say with JUnit, it has very few unit tests. So really want to try to bang on it when it comes to higher level tests at least until those unit tests get filled out. Past bugginess, this is another one, right? This code was found to be soft in the past. Frequency of use, another one, if this is coming up all the time, or feature importance to the user, you really want to get that right. So there's a notion of buddy testing, which is different from pair testing. Pair testing would be two people sitting side by side developing tests. Buddy testing, here you have developer A writing test cases for B specification before B begins coding, and B does the same for A. So basically, there's some spec that communicates what needs to be accomplished, and someone else writes the tests for that, and then you write the code in their test running your code. And there's some advantages to this. Better activity. Someone if someone different is writing the test, they may come to it with different assumptions without the same assumed interpretation, and may reveal inconsistencies in understanding, may reveal oversights, right? Also, having the test cases available before coding can help improve understanding and consistency of the code. So often those test cases that are written before it are typically shared with the developer so they can write code for it. And frankly, when people write tests for their own code, they do so often in a sympathetic way. They write tests to show that it's working, not writing tests to try to make it break. And you can write tests to try to make things break much more aggressively than is typically exercised in unit tests. And finally, this spreads knowledge. It spreads knowledge about how this part of it works. So if that person drops out of the class, if that person becomes sick, if the person has to go to a higher priority job because someone else dropped out or was sick or what have you, if suddenly they have to serve as build master, you'll know how that area works. Okay, I've recommended to at least one person in this, one project manager, the use of bug parties. These were a big success. Were those mentioned on Tuesday at all? Yeah, okay. It's a great morale building activity. It takes the sting often out of finding bugs in your own code. If you kind of get together and you try to break the code as a whole, and you view that as an aspect of sort of group fun, it makes it less likely someone will take it really personally, that their honor is being impinged by the fact that their bugs have been found in their code. So the idea here is to do ad hoc testing, try to find bugs, improve inventories of bugs, improve coverage, and it's often a lot of fun. bugs, etc. It says most bugs, but that should be bugs. So, you know, here typically you're also trying to create test cases. Trying to define test cases. It's true you may be doing this on a very ad hoc basis, but you're going to want to try to think about how can we leverage the insights from this to actually create test cases that will then automate these tests from now on. Maybe, you know, often what will happen, you bring a bunch of people together like this, you get really creative about it, new ideas come up for how to test this thing against whole new classes of bugs. And you should be sure to try to capture that information during the bug party. Maybe you want to have someone whose job it is at the bug party to serve as kind of a recorder or serve as a observer, and they'll write down, you know, significant finds. They'll write down the you know, interesting observations or new ideas that have come up. So they're one step removed. They're not in the thick of it trying to come up with test cases. They're more observing what's going on, seeing how the ideas, what ideas are being productive in terms of finding bugs, what areas of the program are proving productive. You certainly want to make sure that the bugs that are identified are remembered so they can be fixed. Okay? So bug parties are often simultaneously morale boosting, important for getting a sense of overall quality of the product, very helpful for identifying not just new bugs, but new types of bugs. Yeah?
Would it be overkill to use screen capturing software during a bug party session? Because then people don't have to constantly write down the whole if something unexpected happens.
No, I think it's a good idea. I've done some similar things before. The only question is if you have a lot of people and they're each doing it, you know, on their own machine doing testing, how to avoid just having such a large number of videos available that it becomes unmanageable. But I guess the key point that you're addressing here is that, like for a given tester there, maybe, you know, 98% of their time you don't have to really worry about it, but it's, you want to be able to go back to those key couple things that happened perhaps, so you can replay it. What was I doing, right? Because that's the issue often with manual testing. If you do it in too unfocused a way, what the hell, you just kind of frog it in kind of a desultory way, you may find something happens, but you weren't really paying attention to what you were doing. So you either need to write it down or screen capture, and then you could go back and record, okay, I did this step, but then I clicked on that, and for that one I left an empty field. That may be helpful. That may be helpful. It's just, don't assume that everyone's going to go through all of the screen capture. It'll really be on those focused times where you found something. Right?
I was thinking more of using it during the bug party so that while they're doing this, especially when there's lots of people around, we're not really chatting back and forth,
Right.
cracking jokes and whatnot. So having that, when they do come across the bug, oh, I'm going to go back and review the last 30 seconds
Yeah.
and accurately record those steps.
Yes. Yeah. No. I think that's good. I mean, it's good practice also to jot things down while you're doing it, but this can make it more fluid if you can actually just rewind, as it were, and watch. Okay, exactly what steps did I take? That could be good. Hopefully, in the course of doing this, you'll come up. I mean, it shouldn't just be, you know, 100 monkeys pounding on it. It should be, there should be some evolving theory as to, you know, oh man, this breaks really easily. You know, let's try going after this. Or oh, that's a clever technique you're using there. Let's see if this other field using the same technique, you know, it'll also crash in the same way. And so there should be learning that's going on, is I guess what I'm thinking about, and structured thinking about, okay, how do I best go about doing this? I mean, if you just test it with random data, it gets you somewhere, but often the most valuable testing would be sort of clever cases that the developer wouldn't have thought of, and you're able to exploit those. And there should be, as you say, sort of a communication of ideas, cracking jokes, but also, oh look, this worked really well. Let's try that elsewhere. So that's good. Hallway usability testing. Both projects this year are focusing on building systems grabbing a few people outside the class, outside of computer science, to try a user interface. This is, a couple of years ago we had archaeology, and so if they could grab someone from archaeology, it was really effective. There's a comment by Jacob Nielsen who writes on the usability front, why you only need to test with 5 users. And the idea is there's a diminishing return. There's a diminishing return. So you test it with the first couple of users, you start to get a sense of a lot of the big issues that are often in common. Okay? So hallway usability testing, really lightweight. You just try it out with a few people from outside of CS, and you often get some pretty good feedback from that. Feedback that's good enough you can start to incorporate it into your system. I want to talk about regressions. This is highly, highly testable. Highly quizzable. Almost as much so as your name. Let's talk about the issue of regressions. The term regression is used actually quite a bit in the testing area in professional software development. But it carries different connotations in different sub-areas of that community. And combining two of those definitions, regression is when a given change to a program, a given update to a program, breaks a feature or operation that previously worked, or if a previous bug, a previously fixed bug, reemerges. Okay? So there may be a bug that was fixed before and now it comes back. We call that a regression. But another regression is this feature that used to work now fails to work. You can think of the bug there being, there was no feature previously, and now that's reappeared as a state. And we sometimes speak about a regression test gap as being the difference between the things covered in the current test set that's routinely run and the entire test suite historically that's ever been run, a set of all tests. Because if there's a gap here, we might find there would be things that we would have found if we ran these older tests, but instead we're finding a smaller set. There's a gap of sorts in our knowledge of bugs. So there's a serious risk of regressions without us knowing about it. There's one of these test gaps. Okay. Now, the key point here that I want to emphasize is, and it bears understanding, that first of all, there's a high risk of reemergence of bug fixes. Bug fixes are very problematic. Often, the statistics on these are sobering. If you modify less than 10 statements in your bug fix, only 50% of bug fixes tend to work. Okay? So a lot of the time, you think you're putting in a fix, and it's actually not fixed. Modification to 50 statements, about 20% of bug fixes work. And there's many reasons for it. There's problems with logical reasoning, or you fail to check certain assumptions, you misunderstanding the bug report, misrecalled when you claimed it fixed, or you wrote specialized fixes which fixed, for one particular case, but which led it to still broke. Okay, so let's talk about regression though. So again, I noted that regression tests mean either that verifying regression testing means either verifying a fix actually fixed the targeted bug, or verifying that a new development or bug fix didn't break features that were working earlier. So you want to make sure that these bugs that were fixed before haven't come back, that they're truly fixed, and you want to make sure that this functionality that was there before worked. Now, older bugs reemerge frequently. Involve tricky parts of the design, misunderstood. Things are misunderstood in similar ways. There could be merge conflicts, which reintroduce a bug. Do you know what that means? Merge conflict? What am I referring to there? Sorry?
SVN.
Yeah, well, it's not just SVN. It could be SCCS. It could be RCS. It could be Git. But basically, you have a situation where you have two people working on the same artifact, and they have to merge. They've both been working on the same time, and they have to merge their changes, right? And when they merge their changes, it could be that the code reverts. As far as the code you had fixed, it reverts to its earlier, some element of it reverts to its earlier version. So your code that fixed the bug literally gets thrown out, and this other code comes in. So we'll commonly want to test all previously found and closed defects that are no longer present, test similar bugs, and test against other features that to make sure they're not tests. Now this is the key table I want you to be able to reflect on and remember. The reason we care so much about regressions in terms of features that used to work which no longer work is that they can be absolutely deadly to users. They can be one of these things that, as I put it on an early lecture, deliver negative value. If a regression occurs, a feature that is an existing feature now fails to work, it can be very problematic. Worst case, if it's detected by a post-release user, if your website has gone live, or this system you shipped it as code to a client for consulting, and they've rolled it out across their company or what have you, it's disastrous because they may be using workflow which depends on this feature, which depends on this ability to use the software in a certain way, and now they can no longer use that functionality. And typically there's a high cost of repair, disruption of key customer workflow while it's still unfixed, loss of image, possible liability. You are getting in the way of their work. By contrast, if it's a new feature that just doesn't work, well, it's a little bit embarrassing, but they're not already counting on it, right? They're not building their company around the ability to use this, as they would be with an existing feature. With an existing feature, it is just disastrous if they can't open their document they've been working on previously, or if the document crashes frequently and it always used to work okay. If this whole area of the system that they've been relying on for the past 6 months is suddenly unavailable, their processes could be greatly disrupted. Now, ideally, it'll be detected earlier, but often existing features, it can be high cost to detect because you're focusing on the newer functionality, and it can require additional time to repair because it's unfamiliar code. It's not code that's been modified recently. It's established code. Established design elements that were there before and which you may have not be really, really familiar with. So often, even if you catch it earlier, it's an extra pain to sort of fix. But it's particularly key that if something occurs that jeopardizes this, you catch it soon. As far as new features, yeah, there's a cost and delay to fix, and those can be really significant. But no one's counting on it yet. Worst case, you can probably deep six it for this incremental release, plan on working on it for another release. Sometimes there are problems with that. Like a new feature, you might not be able to just surgically remove because other features which the user is counting on may depend on it. So it's not always so easy. But big picture here, folks, what I really want you to remember is the fact that regressions, particularly where it involves breaking an existing feature, are horrendous for users. They're a type of bug that's particularly disastrous. And that's why we run regression suites. Tests that are designed to confirm existing features still work and that old bugs are still fixed. These bug fixes, these tests that used to fail with bugs work properly still. They're not failing again. So we run whole sets of things called regression suites. Typically those are too, and eventually far too large to run in a daily build or a continuous integration cycle. So instead the test team will run them after they get a new release of the product. They'll run these regression tests. And they might take 2 days to run. You can imagine a larger program just accumulating these regression tests. All these bugs that have been fixed in the past, you can be testing if possible. All these different features, you're going to be making sure they're working. Those regression tests, you're going to want to run on a regular basis. The test team will want to run them, but they're not typically going to be part of that build. Okay, so existing features, breaking them, bad, bad, bad. Capital B, capital A, capital D. Defect tracking systems absolutely key. You folks want to use Jira, or you want to use Track, Redmine, what have you, to track defects. Know when a defect is introduced. Know when it's been sanitized. What does sanitization mean? Give me an example. What's a bug that's not yet sanitized? Could be a what? Could be a yeah, a duplicate. Good. Excellent. What's another thing? False positive. Yeah. It may be against a code base that's old, so it's not current. It may be something which is based on a misunderstanding and therefore doesn't necessitate a bug fix, although it might necessitate better communication or better documentation or something. So you want to know when it's sanitized. You want to know when it's been properly promoted, therefore to an active bug. You want to know when it's been triaged and decide that it's worth fixing. These are all important things. You want to know who it's been assigned to, what its current status is, whether it's believed to be fixed, etc. Okay. Test escapes, customer-identified bugs are really, really valuable. And you're going to want to use them to strengthen testing process. If a customer finds a bug, if you're demoing your systems to the user and the user discovers a bug, you should be asking yourselves, how did this creep through? What was it that allowed this to come into being, and what was it that allowed it to escape all our tests? How can we learn from that as effectively as possible? It can help you identify whole areas of the system where defects may lie undiscovered. Provide basis for regression testing, and it can help lower the chance that customers will be alienated. What's that?
What would you say about severity of test or a crash during a user seeing a crash versus you finding a crash?
Well, generally speaking, I think it's
that's worse, right? That's a high severity.
It's a high severity thing. I mean, among other things, customers get alienated, they lose confidence, all sorts of worries come up. And part of the problem is when they see a crash, you may say, "Oh, that's just this dumb thing, about the latest service pack not being installed or something like." To you, it's like, okay, you see through it. This is not a significant thing. For them, they don't know. I mean, yeah, I mean, it may mean it's the year 2000 bug, or it could be an indication from their perspective that really